All right, welcome everyone. Give me a thumbs up if the audio is good. Let's see. I'll make sure everyone can hear me. Awesome. My name is Roland Barcia. I'm the Worldwide Director for our Specialist Technology team, and I have the honor and privilege to be here with Mridula. You want to introduce yourself?
For sure. Hello, everyone. My name is Mridula Grandi, and I lead the go-to-market for North America for specialist essays. I'm happy to be here and be talking about unlocking agentic AI for microservices.
Thank you. Thank you for joining us, by the way, in the evening, 5:30. Not a great slot. I know people want to go have nice dinners and things at this time, so really appreciate you all being here. Thank you so much. So let's get started. I'm going to go through the animations quick, because I really want to have a conversation with the audience. I wish it was a little bit more two-way here, but obviously AI applications have really exploded. I mean, how many sessions were there this week with the word agents in it? Agents is everywhere. We're entering the agentic age, and it's really important to understand what that means for your existing systems, your existing microservices, your existing applications. I want to get started a little bit with agent-driven design and agent applications. We spent many years building microservices. Mridula is going to talk about that in a minute. But agentic applications have really emerged as a new pattern. And there's a lot of differences between them. So for example, very stateful applications, very data intensive, very conversational. There's a lot of different principles. The DevOps is different in many ways. You're doing things like evaluations. We announced AgentCore Evaluation today, for example. We're doing things with ML ops. We're doing a lot of different things with data. We want to make sure we can get at the data, get insights from the data, and we want to make sure we have guardrails. We want to make sure it's enhancing human ability to do things faster and more effectively with more quality. And these are all aspects of agent-driven design. Now, a lot of the early agentic applications were static workflows, oftentimes stitching together agents through workflow tools, BPM tools, etc. We worked with a telco provider. One of the teams I run is the prototyping team. And we spent a lot of times helping customers build their first agent use cases. This one is a very interesting one for me. And it kind of highlights some of the themes we're going to talk about. We worked on this SRE agent. And what we wanted to do is have a metric, a goal. They wanted to get from 30, 40 minutes problem resolution down to 5 minutes. And so, we can solve this with agentic behavior. But a lot of the things and systems they needed were locked inside of applications. And so they wanted information about their Kubernetes EKS cluster. They wanted information about their metric server. They wanted observability information. And they had built a wealth of knowledge around runbooks. So we built these existing systems and exposed them to the Model Context Protocol. Mridula is going to talk a little bit about that later. That's MCP, if you're living under a rock, is like everywhere, right? There's like probably more MCP servers than there are people using MCP servers in many ways. But we built an SRE agent that really modeled workflows after their existing patterns and runbooks, and they were able to really resolve a bunch of the issues that they had in production a lot more quickly. And these are examples of the power of taking your existing deterministic code, deterministic operations, and exposing them through a common API, and then being able to build orchestration and workflows. And they were able to not only get to what is the issue quicker, but actually take resolution steps with agents and take actions on them as well. This is the power of agentic behavior, being able to stitch these things and automate the things that we want to automate so we can focus on value. But microservices is a challenge, and with that, Mridula is going to talk a little bit about some of this.
All right, let me start with a question for the room. How many of you are actually running microservices on production today? On a quick show of hands.
Should be everyone.
That's awesome. And keep your hands up if you have agents already accessing them on production. Okay, that's what I thought. Welcome to we've been running microservices on production successfully, but now AI agents want in club. Think of it like this. We've either started directly with microservices or decomposed monolith applications into microservices. We now have a fleet of microservices, each with its own API, databases, business logic. All the services are talking fluently in REST, but agents only understand vibe coding. Just kidding. When we are bringing agents into the enterprise world, agents that can plan, reason, break down tasks, execute the tools, and actually achieve the outcome that you want them to achieve. And when you expose them into the microservices world, they'll be like, OK, cool endpoints. What do you want us to do with it? This is where the context engineering comes into picture. In the microservices environment, context engineering is where you tell the agents what services exist, which ones it's actually allowed to call, in what order, under which preconditions, and how do you recover from failure. And if it's actually done right, you're turning a flat list of APIs into a map of capabilities, constraints, and workflows, exactly the environment that agents can thrive. So the real problem is actually not the logic. The logic is already existing in your microservices applications. The real problem is the exposure. How do you surface the already existing logic that's there in your microservices into a structured, contextual, and a truly agent-friendly way so that your agents can start talking to your microservices in the new agentics and build the new agentic systems? Now, think about it from your environment perspective. What does it take for you to actually expose your microservices to the agents so that you're truly unlocking that value and actually unlocking to the next level of enterprise scale agentic automation? Now, before we dive deep into AI agents, let's make sure that we are actually all speaking the same language of microservices. Foundationally, a microservice is a simple deployable unit that has a specific business function and can talk to each other and also external data sources through REST endpoints or well-defined endpoints. Right? Think of it like Lego blocks. Each block has a specific function that does it well, but when you snap them together, you're actually creating something amazing. Now, there are 6 principles of microservices that I want you all to underscore. First is service independence. Each service is a standalone application or with its own database and deployment lifecycle. Think of it like roommates with separate bank accounts. Second is single responsibility. One service, one job, done well. Third is decentralized communication. Services talk in well-defined endpoints or APIs, not directly access the database. Fourth is agnostic tech stack. Service A can be written in Python, service B in Java, service C in Rust. Do whatever fits well. Fifth is system resiliency. One failure doesn't crash your entire application, just like a flat tire doesn't bring the entire highway down. And the last is the independent deployability. You can deploy, update, and roll back your services without impacting other services. These 6 principles are what make microservices powerful. And once you master these, you're actually ready to understand the AI agents and how it unlocks to the next level. Now, let's look at how some of the aspects that we discuss on this slide could be helpful for you to think about rethinking microservices in the agentic era. Now, on the left, you have the core microservice constructs. You've got your data layer, where you store your databases. You've got your events flowing through the message queues. You've got your business logic, the code that makes the decision, the brain of your business. And if you've got your communication, the REST APIs talking to each other. Pretty straightforward. Now, on the right, what you have are the AI agent core constructs. And when you infuse these into your microservices, you're adding 4 new capabilities. The first is the reasoning. Reasoning is the agent's ability to solve problems. Chain of thought is the agent explaining its reasoning out loud. Chain of thought transforms what you see as a black box to actually a glass box because you get to see every decision that is being made, and especially that's important when you're orchestrating your services in a production environment. Next is the memory. You have two different types of memory, fundamentally, and today we've launched episodic memory as well, and we'll talk about it later. But the short-term and long-term memory, especially the conversational and the operational context, is stored for agents. And your microservices architecture becomes an extensible toolkit that agents can include via tools. And the last aspect is the learning. The agents improvise through feedback loops every iteration of their execution. Now, here's the key difference. The old way, you have to hard code everything. Call service A, then service B, then service C. It's rigid, it's deterministic, it works until it doesn't. The new way is how you actually give an agent a goal, something like reduce incident response time, and it figures out which services to call, in what order, and actually what's happening, and train accordingly in terms of what's happening in your environment. Let's talk about when you should actually use AI agents. It's not about jumping onto the hype train. It's about focusing on three key principles. The first is start with real problem. Use cases like clinical workflow automation for healthcare, where agents can proactively identify your medical history, analyze your patient medical history, identify trends, and flag potential issues, or market analyst agents in financial services, where it identifies the market opportunities to reduce research time so that the investment analysts can focus on higher value strategic work, are some of the examples of real use cases. Determine your key metrics. Things like turnaround time reduction, staff productivity improvements, and time to insight are some good examples of key metrics that you may want to define as KPIs for your agents. And lastly, assess the potential impact. Consider both business value and risk. For business impact, things like ROI, which is return of investment, operational efficiency, customer satisfaction are some of the examples. And for risk assessment, think about what happens when your agent fails. Do you have human in the loop? If not, what would it take to make sure that your services are seamless? So start with high impact problems, define metrics upfront, assess both upside and failure modes, and get these three things right, and the technology becomes the easy part. Now I'll let Roland continue with what it takes in terms of tools and positioning the tools and agents.
Thank you, Mridula. So as we continue here, one of the things I just want to follow up. To be honest, when we're talking about AI use cases and agents, oftentimes some of the agents that we're building, it's a technology looking for a problem in some cases, right? The reality is business use cases drive what you need to do. And it could be some of it is deterministic, some of it is non-deterministic. The business problems live on their own. And then AI can kind of help automate, do certain things better, do certain automations better. There's probably lots of things you can look at existing systems and take a look at. That would be easy to automate with AI. If you've ever built business process workflow applications, you've probably seen big branches of like conditional code that goes into like different leaves. Those are good opportunities for agentic modernization. Let's talk a little bit about building agents. More or less, in a nutshell, agent's a piece of code. You might write it in Python, Strands. We just announced Strands TypeScript today, so really exciting. We can write some agents in TypeScript. There's other frameworks, and you're really doing a combination of goals and instructions. So you have your prompts, your system prompts. You have your tools, your deterministic logic. We gave examples of that earlier. And then you have things, your context. Context engineering is really becoming very strategic in guiding the agent in where and what decisions to make, what tools to use, what data to go after, what actions to go after. As you build more and more agents, you get a lot of tools, and you need that context to really help your agent make the right decisions. You want to be able to guide the agents you write to make those decisions. And then you have observability. You want to be able to measure the results of the agents, make sure you're getting the answers you want, but go beyond what you get in chatbot today is like thumbs up, thumbs down. Did you like the answer? How do you do observability and successful metrics in an observable way? These are some of the challenges around that, right? Agents need tools and they need content. And there's different ways to do this, right? There's web scraping, navigation, interactions. LLMs are good. There's techniques like LLMS text files that you can put into websites, for example, to help models. You have workflows and automations that you need to do tasks. Usually these are located inside of MCP servers. That's what we want to get out of our existing applications. Then you have knowledge bases as well, and you have your existing data. And that data is structured and unstructured. So this is definitely the things that the agents work with. Some of those things, again, are available there. I'm going to give it back to Mridula to talk a little bit about MCP.
Thank you. All right, remember the early 2000s? Every device had a different power adapter. It used to be a nightmare to manage all of those. Then USB-C happened, and that's exactly what's happening right now in the AI agentic space. Especially when we have so many agents talking to different tools and content, we need an adapter to make sure that all of this is flowing through seamlessly. Model Context Protocol is an open source protocol developed by Anthropic and is emerging to be a standard operating protocol along with the agent-to-agent. But specifically when it comes to agents talking to tools, MCP plays a critical role given the fact that MCP is better with respect to agent-to-tools communication. So we will dive deep on this protocol, followed by Roland taking over on A2A. So MCP follows a client-host-server architecture for your agents. Firstly, the host has your AI agents, LLMs, and IDEs that will be requesting access to the data sources. Then you have the MCP client, which maintains the one-to-one connection with your MCP server. And an important thing to note here is MCP client can establish multiple transport layers, which means that you can actually get a mix of deployment modes without having to rewrite agentic code. The MCP server is a lightweight program that exposes the capabilities of your microservices through the standardized MCP protocol. And lastly, we have the data sources, both local resources like databases and files, and remote services via APIs can be accessed through the MCP server. So the key point to note here is MCP is action-oriented and deterministic. All it takes care of is the protocol translation, but not the decision making. That's where your agents come into the picture. Now, before MCP, building GenAI applications was like a plumber in a house where every room has a different pipe standard. Your application needs to call GitHub, custom integration. Slack, another custom integration. Your own databases, yet another one. Each with different authentication methods, data formats, and communication protocols. So if you have about 5 applications talking to 10 different tools, you have 50 different integrations. And here's the kicker. When Slack updates its API tomorrow morning, you'll end up rewriting that code across every single application that invokes the Slack. It's a nightmare to handle the integration complexity and not exactly the future that we've signed up for. With MCP, you get one unified API layer. Your application needs or speaks to one protocol, that is MCP, and the protocol handles the translation to each service's unique API. One integration point for your application, but actually standardized access to an expanding list of tools. And that's the fundamental shift we are talking about from custom integrations to standardized simplicity. From spending weeks debugging the authentication methods and API versioning to shipping AI features in hours, if not days. Now, Roland is going to cover the A2A.
Yeah. And so we wanted to cover this a little bit. We're not going to go too deep, but as we're thinking about microservices, one of the big things about microservices was always reuse, right? How do I reuse my existing applications? Comes to agents need to do the same thing. I need to build agents, and they're used by other agents. That's how you build orchestration, non-deterministic workflows, calling other non-deterministic workflows. And A2A really addresses that problem. One, there's tons of agents out there, so how do I discover them? The A2A protocol has a discovery mechanism. Task management, you have different agents that do different tasks. Collaboration, how do you share things like context? How do you share things like security, et cetera? And these are important things to talk about when you're building agents. You want to think about your agents the same way you think about microservices and expose them to other agents and other orchestration and other tools and even front ends. I actually had a code talk earlier today. It should be up on YouTube already. That kind of shows an example of us taking an agent and exposing it through MCP and deploying it to AgentCore Runtime. So let's talk a little bit about now the process of like going through and taking your existing applications, your existing microservices, exposing them through tools, right? You want to define, describe your APIs. How many people use things like Swagger in the past to define RESTful APIs? Well, Radula talked about microservices principles earlier. The reality is we probably haven't written perfect microservices that have one data source per microservice and do all those things right. We probably have a combination of like monoliths through microservices, and maybe you don't have those APIs. You can use something like Hero to generate some of those open API Swagger documents. Right? You want structured interfaces, so JSON, Open API, gRPC, or other metrics. You need security and guardrails. How do you access them? And then you need feedback loops, observability, retries, et cetera. Now, when we're getting into exposing your microservices, there's choices. You can code and write your own MCP servers in code, make it part of your application, maintain it with your code. There's nothing wrong with that. Oftentimes, why would you do that? You want to take full advantage of the MCP protocol. In addition to tools, it has things like resources and prompt templates, so you want to be able to standardize on those. You might code some special purpose MCP servers, but when you have hundreds or thousands of microservices, you may want an easy button. And that's why having something like AgentCore Gateway, which we'll talk about, to kind of expose your existing tools as MCP servers might be a huge accelerator for your existing systems. So you can kind of think about which MCP servers you want to code, which ones you want to expose, which ones you want to combine, et cetera, and have those capabilities. A lot of the early MCP servers that were built out were read-only, right? So we'd have an ordering agent, pricing agent. You go to MCP Gateway, you go get your promotions or list your promotions, et cetera, and then kind of goes into your existing systems, accesses your presentation layer or your REST APIs, your BFF services, best friends forever, or back end for front ends. That's what that means. And then kind of expose it. And that was easy. Some of the security behind that's a bit easier. But now things are evolving, right? So, you're going to have lots of existing APIs. You're going to have lots of existing MCP tools, right? And then you're going to have MCP servers. And then you could expose them through a gateway to make things a lot easier for you, right? There's different patterns with MCP gateways. For example, you might want to get REST APIs. You might have existing Lambda functions. You might have existing MCP servers, et cetera. And we didn't catch the typo. My name was in the header there. Oops. And so some design principles, right? When you're building model-driven approach to agent, you want to think about your consumers. We have developers. Some agents are going to be naturally consumed by developers. Some agents are going to be consumed by business users. I know we have a lot of low-code, no-code tools like QuickSuite, which is an awesome way for your BI people to build agents and automation against your different data sources. But you want to be able to get and build for developers, simple code solutions, you want reasoning capabilities, and you want model and deployment choices. So the reality is it's building agents is hard. I would say building them, building examples, building POCs are fairly easy. Getting them to production is hard. Learning all the best practices is hard. You have to start thinking about things like, I have hundreds and hundreds of MCP tools, and then I send a request. I said, give me a list of tools, da-da-da-da. I get the answer back, and then I tell the chat agent, thank you. What's it going to do? It's going to send thank you back with the list of tools and the context. You don't want to pay for the tokens for the list of tools and build that up. Lots of different new best practices that are emerging around those things. And so we control, guardrails, all these things, limited visibility. Observability is a challenge. Things are generated, you get responses, they're dynamic. It's really hard to observe dynamic code, right? So it's challenging, it's hard to maintain. Why? Because models keep coming out, new versions of models come out. You start building up a prompt library of things to test, answers, and then, brand new model comes out, you run your tests, and all the answers are off, right? So DevOps and MLOps crashing together, different things. And so Strands really helps with a lot of this. Mridula, you want to talk a little bit about Strands?
All right, let's talk about Strands agents. Strands agents is an open source SDK that lets you build AI agents in just a few lines of code. Amazon has actually built this and published this as an open source. No complex workflows, no orchestration nightmares, just you, a prompt, and a list of tools. Why should you use Strands? Let's start with ease of use. Remember the last time you tried to build an agent and spent 3 days figuring out the orchestration framework? With Strands, it's just 4 lines of code. You've got a working agent. No YAML files, no complex configuration, no sacrificing your weekend to Stack Overflow. Internally, our Amazon Q developer team used Strands to publish our agentic chat in just 3 weeks and GitLab Duo integration in just 6 weeks. What previously took months now just takes weeks. And that's the difference between we'll have them ship next quarter versus we've already shipped them last Tuesday. When it comes to robust capabilities, Strands comes with about more than 20 pre-built tools, whether it's file requests, web services, operations, and custom integration with AWS service tools directly. So if you want to integrate directly with Glue or Amazon VPC Reachability Analyzer or even a Snowflake database, MCP got you covered there. And Strands got you covered there through MCP because Strands comes with a native MCP support. And we've also recently launched 8-way support for Strands. Extensibility is where Strands really shine because you are not locked in on one single model provider. You can use Amazon's Bedrock, Anthropic's Claude, or any other Mistral AI or Stability AI model provider. The choice is yours, and we have support over 100 LLM providers there. So rapid development means you get to go from idea to working prototype in minutes, not days. You can test easily on local machines, iterate fast, and deploy to production whenever you're ready. So given the agents are autonomous systems, even building a basic agent requires piecing together numerous complex components such as orchestration, tool execution, and state management. Open source frameworks like LangGraph, CrewAI, and Strands agents are making it easy for developers to get started and build prototypes. While these frameworks have simplified building a working agent prototype, developers still hit a brick wall when you attempt to actually build an application that can scale to millions of end users in production. So I'll let Roland unpack the key components and the challenges that we are facing and how AWS can actually help.
Thank you, Mridula. So let's get a little bit, we've already talked about AgentCore, which we announced earlier in the year. Obviously missing from here is the new policy and the gateway and the evaluation frameworks. But AgentCore, we built it in a very specific way. When we think about platforms, we know a lot of our customers build platforms and they have different choices. So we built AgentCore in a way that you can use the different pieces interchangeably in different ways. So you don't have to use all of it, but if you use all of it, you get a lot of advantages. AgentCore Runtime, which you get into, provides a serverless runtime environment for you to build agents. We have memory, so we talked about things like short-term, long-term summary, episodic, which was just announced today, all these different patterns that were emerging. Identity, which allows us to securely have our agents access securely and also access tools and third-party agents securely as well. AgentCore Gateway, which we're going to get into deeper, really is the ability to expose your existing MCP servers, your existing APIs, Lambda functions, and integrations to your agents. Code interpreter to let you, as you a lot of agents generate code, run it on the fly. You want to do that in a safe sandbox environment, and a set of browser tools and observability to help you see how your agents are performing and doing. And so with Amazon Bedrock AgentCore, right, you can build with the runtime. You can have tools discovered easily semantically through the gateway with semantic search. It saves a lot of money in token costs. Short-term and long-term memory, episodic as well, and summaries, end-to-end tracing and visibility, and full managed browser tools and code interpreter capabilities. Get a little bit deeper when we're talking about applications, right? You want to have an application, want to have an agent. You want to use your favorite framework, as Mridula talked about, such as Strands. TypeScript announced today, release, woohoo! For those people that don't always want to do Python, deploy that into your serverless environment. Talk to any model that you want. It can be hosted on Bedrock with all the model choices. It can be hosted in Silicon like in Trainium, et cetera, Trainium 3, NVIDIA instances, et cetera. Then you have AgentCore Memory for the patterns, ready for production, AgentCore Observability, Identity, all your tools and your existing applications, and your interpreter and browser. This is really exciting because we find getting to production is a challenge. We think we've built a really good end-to-end environment in a modular way to help you get to production. We have lots of customers already in production with agents, with tons of different customers. So Gateway, we have a nice little animation there. We're going to, I think Mridula surprised me with the animation. So, we have the Gateway, which we're going to kind of concentrate into, right? AgentCore Runtime, really exciting. Serverless, but you can take your existing application. All you have to do is put it in a container. You could also do it just the code itself. There's a zip, a faster way to do it as well. But a lot of customers like to deploy containers. They have a DevOps pipeline that knows how to publish to ECR. So you can keep your existing DevOps, deploy your agent as a container, and then it's automatically deployed and running. There's a lot of coding talks this week. Please go see them online if you haven't, especially the one I just did earlier today. Use case independent, very much like microservices, secure, isolated, an isolated environment so that your agent can run without having security boundaries crossed. And so it's very simple, right? You take your agent, your tools and your code, you write your code, your decorators, your different applications, you configure a Docker file, push it into ECR, automatically your runtime agent is there, your endpoints, which could be A to A, could be other types of endpoints as well, and your application can invoke it. Nice and simple. AgentCore Gateway. Now, AgentCore Gateway is fairly exciting. We had a session earlier today, like I said, where you can take your applications, your tools, and expose your APIs. OpenAPI and SMIDI are examples of that. I just opened the console and I saw API Gateway is in there as well. So your AgentCore Gateway can access APIs and API Gateway integrations or third-party MCP servers that already exist. This gives you a unified point in your organization to say, hey, these are our supported, secured, verified MCP tools. With the new policy engine, you can have security policies there. You could say these tools can only be executed by these agents and these different types of patterns that you want with a certain context. And then you have semantic search. Semantic search is really important because you can write an application to do a semantic search across thousands of tools. That won't send all of that to the LLM. Instead, it'll give you back the tools you want and save money. Especially, you could send the list of tools to the LLM, let the LLM kind of determine. But again, you're using a lot of tokens. And if your application knows what tools it needs to use, that's a great pattern for you to optimize and save money. That's why we have intelligent discovery, right? Very simple. You create a gateway instance. You attach it to an identity provider with AgentCore Identity, right? You give it a target. In this case, we're talking about existing RESTful service endpoints. So here's an example of that. And then you go and use semantic search or use the application, say list and invoke the tools, and you just use it. Fairly simple configuration. That's kind of the key with that. You also can do the same pattern with Lambda. We have lots. How many people have lots of Lambda functions deployed in production? Lots, right? So you have your Lambda code, your Lambda targets. Lambda could be a good, quick way to stitch things and support patterns that we might not support yet. For example, you might have private APIs that are not accessible through a VPC, et cetera. You can use Lambda to kind of bridge those gaps and things like that as well. Lambda is a great stitching tool for that. It supports things like OAuth with AgentCore Identity. We actually showed the code for this in the API Gateway with Containers application, where we actually used a Python decorator as we create the gateway to refresh the token. AgentCore Identity kind of gives you these patterns to do that very simply and very easily. And of course, using AWS IAM to do that, Identity gives you that security capability for it. Very similar, RESTful APIs, as well as some other patterns like SMIDI. And semantic search, this is really, really huge to save money if your agents know which tools they want to do. Get your list of MCP tools, ask it questions, do semantic search, and be able to get the different tools that you might want to use in your application. Search, you get back the 4 most relevant tools that you want to use for your application. You might ask an LLM to do this initially, but you really want to save money and be important there as well. I'm going to hand it over. We're doing a switch on purpose. We thought it would be funner to do it this way because we're being agentic. Right, here we go.
All right, here's the challenge with agents and microservices. Traditional microservices are stateless by design. They don't remember anything between the interactions. But AI agents need context to be effective. Without memory, your agent starts from scratch every time, leading to repetitive questions, slower responses, and higher costs as you pass the context and the same context over and over to your LLM. AgentCore Memory solves this by automatically storing and indexing your agent's interactions in a serverless architecture. As a result, it reduces the amount of context that you need to pass to the LLM, which means faster responses, better accuracy, lower costs, all while maintaining enterprise-grade security with encrypted data isolation. So AgentCore Memory works very similar to how human brain remembers information through context and associations. Short-term memory handles your immediate context, like chat messages and session state, keeping track of what's happening right now in the conversation. Long-term memory is where the real intelligence emerges. It stores the semantic information, user preferences, and summaries that persist across sessions. And episodic memory captures specific preferences and experiences and events with their temporal and contextual interactions, like remembering particular conversations, what decisions were made, or problems solved in that past interaction. The magic is in the automatic memory extraction. The system asynchronously processes and organizes this memory so you and your agent can actually retrieve relevant context from past interactions without you having to manage any infrastructure. That's the key aspect. This means your agent learns and improves over time, remembering user preferences, improvised past solutions, and the specific journey of interactions that lead to the successful outcomes. Here's a fundamental challenge when it comes to AI agents and microservices that are set up in a distributed system. And when it's calling enterprise services, whether it's GitHub, Salesforce, or even AWS resources, you're dealing with a complex web of authentication methods. Traditional approaches force you to build custom authentication flows for each service and migrate users, or even create token management systems that are often brittle. AgentCore Identity solves this by providing secure delegated access across your entire enterprise. And this is done by providing secure delegated access across different services, whether it's Okta or Microsoft Entra ID or even Amazon Cognito. You don't have to migrate users. All you have to do is make sure that you have your credentials, whether it's through the keys or the IAM roles, and you can accelerate your agent development without having to rebuild your authentication infrastructure through this. Now, the authentication works in two directions, both inbound and outbound. Inbound authentication handles how users and applications in your microservices actually invoke your agents, whether it's through IAM or AWS resources. And this is where AgentCore Gateway validates who's calling your agent, and even if they're allowed to do so or not. Outbound authentication is where your agent authentication to external resources and services are done on behalf of the user. And when your agent needs to call the GitHub API or query Salesforce, or even access your AWS Lambda functions, it uses the appropriate credentials, whether it's OAuth tokens or API keys or IAM roles that we discussed, all managed through a secure token vault. And the beauty is that AgentCore Gateway handles both inbound and outbound with a pre-built-in authentication and observability, so you get the enterprise-grade security without any custom code. Now, agents are non-deterministic by nature. They make autonomous decisions, call multiple tools, and execute complex workflows. Without visibility, you're actually flying blind here. And when something goes wrong, you can't debug it. When performance degrades, you cannot diagnose it. And when you need to maintain quality and trust with your end user, you have no evidence to show them. This is where AgentCore Observability solves this by providing comprehensive observability and visibility into agent execution and operational metrics across all AgentCore services. You get real-time dashboards that centralize agent health and performance for faster issue resolution. And you can accelerate your debugging capabilities to quickly detect issues and assess performance trends. Custom attributes and metadata are something that you can actually customize. And we've recently launched AgentCore evaluations, where it enables to systematically assess agent quality through success criteria that you can actually configure through evaluations. Now, how the system works is through a centralized observability architecture that collects the telemetry from all the AgentCore components, whether it's runtime or gateway or identity or memory, and your tools through the microservices. As your agents execute, AgentCore automatically sends traces to the observability component, capturing every decision, every tool call, and every interaction that was made. The logs are open telemetry compatible, which means that the logs can be directly piped into your choice of observability platform, whether it's Dynatrace or Datadog or Langsmith or Langfuse. You can easily add random and custom attributes and business metadata functions to your agent traces, making observability directly relevant to your business outcomes and decision making. Now that covers our AgentCore modules, and remember that these are all modular Lego blocks, so you can pick and choose whatever fits your production environment. And with that, I'll hand it over to Roland to do some closing comments.
Thank you. Yeah, I'm really excited with observability's OTel support. Lets you kind of integrate with your existing observability tools, because we love our observability tools, but our partners also have some great tools. So really excited about that as well. Still a lot of challenges in this space, right? Cardinality and token costs. You have lots and thousands of microservices, and you have to interrogate all of those things, right? And you're sending those over to LLMs to make choices on your applications. That can bring up the cost. That's why things like semantic search and using that are so important, right? Auditability requirements, the more regulated your industry, the more you have to think about things. When policies are changing fast, how do you deal with that? Lots of issues there as well, right? A lot of regulated industries require precise, deterministic logic. That's why your code is super important. You're still going to write your microservices, still going to write your container-based applications, EKS, ECS. A lot of cool announcements there this week as well, your Lambda functions. And you're still got to deal with things like data trust, permissions, and all of these things. And I'm really excited with the frontier agents that Matt announced earlier yesterday, right? These agents really implementing, Swami talked about it, kind of some of these DevOps challenges that we have, MLOps, evaluations, and really streamlining that. But there's still a lot of things to kind of worry about with your existing DevOps, your existing applications. You might be using GitOps, DevOps, different things, and now you have brand new patterns. So these are still lots of challenges. Hopefully we work together, discover them together out there in the ethos as we work together and build our systems, right? In summary, our use cases must be business driven, right? At the end of the day, you must have valid business reasons to build applications, build systems, whether it's to save costs, whether it's to provide new opportunities, certainly not lots of new patterns, generation of tools, making it easier for your applications to kind of create content, lots of different use cases. Use Accelerator, lots of best practices in places like our solution library and marketplace, and all different places have different accelerators and best practices. Integration continues to be important. Things like gateways will really accelerate your existing applications. Define your development methodology early, your MLOps, your evaluations, your DevOps. Harden those practices when you build your first agents, and then over time, harden those practices as you learn more and more. It might be building up a library of prompts, introducing new practices like LLM as a judge to kind of evaluate as new models come out. So with that, I want to thank you for spending your evening. I hope you all have great plans this evening as you go out and think about these things agentically. Think about making decisions over your dinners, what you're going to eat agentically. Thank you. We'll share the QR code, start building with AWS, and use our Bedrock AgentCore capabilities. Thank you.